Welcome to today's Explainer. So today we're diving into Chapter 11, and we're actually taking math right off the textbook page to discover the fascinating geometry that's basically hiding in plain sight all around us. Get ready, because we're going to look at the everyday world in a completely new way. Think about a ticking wall clock and, an old school CD. What do they actually have in common? Well, you might immediately say they both spin. And sure, that's true. But the fundamental answer is their perfect continuous shape. Today, we're demystifying the geometry of circles. Here's our roadmap for today. We're going to cover spotting circular shapes, drawing perfect circles, figuring out positions around a circle, creating some really cool circular designs, and finally, folding for right angles. Okay, let's dive right into this with our first task, spotting circular shapes and finding geometry in the real world. So if we're putting our strict mathematician hats on, we have to classify our world really carefully. Things like a drum, a sieve, a car's wheel, a steering wheel, the rim of a teaspoon or a pot, these feature a continuous, perfectly round shape, right? They are truly circular. But what about a mathematics textbook, a cricket bat, a winnowing fan? Well, they might have curved edges or straight lines, but they definitely don't meet the strict mathematical criteria for being a circular shape. Moving right along to hands-on geometry, let's talk about drawing perfect circles. I want you to try this yourself. Just grab a small circular object nearby. A 2 rupees coin, a cup, or even a saucer works perfectly. Place it flat on a piece of paper and carefully trace its edge. It's really that simple. Look around your room right now. What else could you trace to make a perfect circle? This whole exercise brilliantly illustrates the tactile reality of geometry. You're literally taking the physical properties of everyday objects and using them to generate a flawless, abstract geometric form right there on your paper. It's kind of like magic when you think about it. But here's the absolute crucial point. How do we formally define what we just created? In mathematics, a circle is defined as the complete curved line of that figure you just drew. Notice that definition. It emphasizes the line itself, the continuous curved boundary, not the empty space inside it. All right, let's shift into positions around a circle, specifically looking at what's inside, outside, and on the line. To really grasp this, I want you to imagine a game of darts. Where would your dart land relative to the circle? Let's consider the landing spots for a few different players here, like Sanjeeva, Sunil, and Pradeep. To make this interesting, there's a very specific point system mapped to these spatial positions. You get 10 points if your dart hits exactly on the circle's line. You're awarded 5 points if it hits anywhere inside the enclosed space of the circle. And tough luck, you get absolutely 0 points if your dart lands outside the circle. Now, challenge time. I want you to mentally apply the rules we just learned. Who scored what? Well, looking at Pradeep, his dart is clearly within the boundary, so he scores 5 points for being inside. Sunil hits the boundary exactly, he's perfectly on the circle, so he earns a perfect 10 points. Meanwhile, Sanjeeva completely missed the shape, landing outside, netting 0 points. It's a fantastic, super simple way to visualize those 3 distinct geometric positions. Okay, up next is creating circular designs. We're going from simple shapes to complex art. The cool thing is, you don't need fancy tools to make incredible patterns. Honestly, just a coin and a ruler are perfectly fine. Just draw a straight baseline, trace a circle resting on it, and then simply move the coin a short, consistent distance down the line to overlap your next circle. Repeat that process about 20 times, and the geometry just beautifully starts to build on itself. And wow, the results are breathtaking when you apply colors to those overlapping segments. You start creating these gorgeous designs that look like flower petals or vibrant targets. You'll actually see intricate math-based art exactly like this on clothing materials, on festival decorations, and intricately painted in religious places. Math truly is the foundation of art. Now, what's really interesting about this next segment is a surprising geometry trick, folding for right angles. Get ready for this one. If you cut out a drawn circle, you end up with a flat, round piece of paper. And in math terms, we actually call this a circular lamina. Fold that lamina perfectly in half, and then, without opening it, fold it in half one more time. When you finally unfold it, grab a ruler and a pencil and trace right over those sharp crease lines you just made. Look at that. Those 2 straight creases you created intersect exactly in the middle, dividing the circle into 4 perfectly equal parts. It is exactly like a clock face sitting perfectly at 3 o'clock. Notice how the hands of the clock form that exact same perfectly square corner that you just magically created just by folding paper. And that brings us to locking in our final geometric concept for today. By folding our circle, we've actually created angles. When intersecting lines divide a space into 4 angles of exactly equal size, the magnitude of each one of those angles is called a right angle. Think about it. You took a completely smooth, curved object with literally 0 corners, and by folding it systematically, you discovered perfect straight edges and right angles. How cool is that? As we wrap up this explainer, I want to leave you with this thought. We've seen today that geometry isn't just some abstract concept trapped inside a mathematics textbook, right? It is the actual blueprint of the objects we interact with every single day. So the next time you look at a CD, check the time on a wall clock, or even just casually fold a piece of paper, what hidden geometry are you going to discover? Keep your eyes open, stay curious, and keep learning. Thanks for exploring the amazing world of circles with me today.